Hi there, welcome to Science with Folly. Today we are looking at alkanes. Alkanes are a homologous series of carbon compounds that share the formula CnH2n plus 2. Homologous, what does that mean? Well, it means they're basically all kind of similar. And what does this formula mean? Well, it means that if I have two carbons, I'm going to have 2 times 2 plus 2, which gives me 6 hydrogens. And there is a simple alkane. And the name of this one, remember our prefixes? Ethane. Eth, the prefix, ane for alkanes. Really simple. So here is our ethane molecule, the different ways we can name it. This is the molecular formula. It tells us how many carbons and how many hydrogens, but that's all it tells us. This is the condensed structural formula. This is the full structural formula, and this here is its name, ethane. Here's the structural formula of another carbon compound. It's got 1, 2, 3 carbons, so it's going to have the prefix prop. It's only got single bonds, which means it's going to be an alkane, and it's propane. Piece of cake. Here's 2 more for us to try. We've got 4 carbons. What's that going to be? Well, you guessed it. Bute, single bonds, ane. Butane. Now here's a tricky one. How many we got here? 1, 2, 3, 4, 5, 6, 7. It goes around the corner, you say? Well, it does. But it's still a single chain. 7, what's the prefix? Hept. Single bonds between the carbons, it's an alkane. Heptane, too good. So what about that condensed structural formula I was talking about before? Well, here is the structural formula of butane, 1, 2, 3, 4. How do we write that condensed? The first carbon has got 3 hydrogens coming off it. The second, 2. The third, 2, and the fourth, 3. So there you have it, the condensed structural formula for butane. And all the rest are pretty much the same kind of thing, just more CH2s in the middle. Sometimes, if you want to be even more tricky, you can put the CH2s in brackets to shorten the whole thing down. Since we've got 2 repeating units, we put it in brackets with a little 2 there, and now we've got an even more condensed structural formula. Here's something interesting. We've got another alkane, 1, 2, 3, 4, 5 in it. It's going to be pentane, but it's got this weird thing hanging off here. It's a branching side chain. And that branching side chain has got 1 carbon. So we give it the prefix methyl. It's a methyl group hanging off the side of this pentane molecule. And to show where it comes off, we count which carbon it comes off. And the closest carbon to the end is 1, 2. It's not 1, 2, 3, 4, because it takes us longer to get there. 1, 2, and so we write it as 2-methyl pentane. Pretty easy, eh? Now here's a tricky one. Look at this one. 1, 2, 3, 4, 5, 6, 7, 8. 8 is our longest chain. I could try counting this way. 1, 2, 3, 4, 5, 6, 7, but that's shorter. So 8 is our longest. So what's that going to be? Octane. Remember the good old octopus? So we've got 8 here, but we've got some branching chains. We've got one side branch here, another side branch here, and another side branch here. This is a single carbon, and this is a double carbon. So this is an ethyl group. This is a methyl group, and another methyl group. So you can see we've got 2 methyls and 1 ethyl. Now where do we count from? Well, we count from this way, 1, 2, 3. This methyl group comes off number 3, 4, 5, and the ethyl group comes off number 5. But if we count from this way, 1, 2, 3, 4, we get to the ethyl group first. So this is going to be number 1, 2, 3, 4, 5, 6. So we've got a methyl group coming off number 3, a methyl group coming off number 6, and an ethyl group coming off number 4. How do we name this? Well, we've got to use a funny rule here. E comes before M alphabetically, even though the methyl comes before the ethyl in the carbon chain, we have to write the ethyl first. So we call it 4-ethyl 3, 6 dimethyl, because there's di means 2, octane. See, you follow the rules, it's actually pretty easy. Now alkanes can also form a ring shape, like this. We call them cyclic alkanes. What do you think this cyclic alkane is going to be called? Well, it's got 1, 2, 3, 4, 5, 6 carbons. Any guesses? I think you've got it right. Cyclohexane. Some alkanes have a halogen group attached to them, and we're going to call these haloalkanes. Pretty easy. Halo for halogen, alkane because it's still an alkane. Let's look at the simplest one. We've got 1 carbon, it's a methane, and we're going to stick a fluorine on top of it. So we're going to call this fluoromethane. How about these two? This one here, it's got 3 carbons, so it's going to be propane, and it's got 2 bromines. Therefore, we are going to call this 2,2-dibromopropane. Follows the same rules as when we have branch chains like methyls and ethyl groups coming off them. Pretty easy. How about this one here? 1, 2, 3, 4 carbons. It's going to be butane, of course, and it's got a chloro and a bromo group. Chloro comes off carbon number 1, bromo comes off number 2. Which one comes first? You guessed it, B, because B comes before C, so it is 2 bromo dash 1 chloro butane. Super easy. And finally, when we look at haloalkanes, we can classify them according to the number of carbons that are attached to the carbon that is attached to the halogen. So in this case, I've got a bromine, can't see it in that color, a bromine. So this here is 1 bromopropane, 1, 2, 3, and it's coming off number 1, but this carbon has only got 1 carbon attached to it. So we call this a primary haloalkane. This one here, the bromo group, is coming off number 2 carbon, so it's 2 bromopropane, and yet this carbon has got 2 carbons attached to it. So therefore, that is a secondary haloalkane. And finally, this one, as you can see, has got 3 carbons coming off the carbon that is attached to the bromine. So therefore, this is a tertiary haloalkane. Can you get a quaternary haloalkane? Think about it. So that's all I've got to say about alkanes today. Hey, it rhymes. So until next time, ka kite anō.